Let's look at this example of how to calculate a test statistic and p-value for one sample t-test. So the problem states that in a 10K race of over 20,000 people, we took a random sample of 50 people and found their average finish time was 57.3 minutes and a standard deviation of 10.2 minutes. Can we safely assume the mean finish time for all runners in the 10K race was below 60 minutes? So we already discovered that the null and alternative hypotheses are going to be mu equals to 60 minutes, and we are looking for evidence that it's less than 60. Also from the data, from the information that was given, we were able to distinguish that we have a sample of 50 people, so n is 50. The average of those 50 people was 57.3, so we have an x bar of 57.3, and the sample standard deviation s was 10.2 minutes. So to calculate our test statistic, we have to remember that all a test statistic is how far away was what we saw with our data, that's our x bar, how far away was that from what we expected, the mean of 60. And we're measuring this as number of standard deviations away, so it's like calculating a z-score, except now we're going to call it a t-score. So using the formula of taking what we saw minus the mean that we expect to see, divided by the standard deviation, we can plug these values in and see what we get. So first, plugging in our x bar, we get 57.3 minus our mean from our null hypothesis is 60, and divided by s of 10.2 over the square root of 50. And once again, we can just use Desmos to get that in here. So on our calculator, I'm going to put in the 57.3 minus 60 on the numerator and 10.2 over the square root of 50 in the denominator, and I get a test statistic of negative 1.8718. So that means what we observed was 1.8718 standard deviations below what we expected to see. So now that we have our test statistic, let's see if we can find our p-value. So remember, what is our p-value? A p-value represents the probability, the likelihood that we are going to see this data from our sample if this null hypothesis is truly correct. So let's find this probability, and when we're doing this, again, it's following not necessarily the normal distribution, but it looks like it. It's going to follow our t-distribution, where we're trying to see what's the chances of getting something less than 1.8718 standard errors below what we expected to see. So we're looking for this area here. So this is using the t-distribution. And remember, when we have a t-distribution, we need our degrees of freedom. So how do we get that degrees of freedom? We have to recall that it's n minus 1. So our sample size was 50. So if we subtract 1, that tells us we have 49 degrees of freedom. And now we can use our p-value calculator, which is the t-calculator. So on ArtofStat, we see the t-distribution calculator. We're looking for the probability of getting our data, so we'll put that in. Degrees of freedom we saw was 49. We're looking at the lower tail. And of course our boundary is negative 1.8718. And so we get our p-value is 0.0336. So the probability of getting something less than that . So there's about a 3.36% chance of observing this specific data from our sample if the true value of 60 is actually correct. So we saw how we can find these values just by finding how far it is away using our formula. And then we can find the p-value, the probability, by using our test statistic and the t-distribution to be able to find that probability. However, we know that ArtofStat is actually a little bit smarter than that, and we can actually give it all this information, and it'll tell us the test statistic and p-value automatically. So let's go through a quick tutorial on how we can do that. So on ArtofStat, if we go down to the significance tests. This time we are doing an inference for a mean. So this is the one we will select. Under the enter data section, we can have our own if we have the actual raw data, the actual numbers, but right now we only have the summary statistics. From here, we see that what are we looking for is the finish time. So I'll type that in as our variable. That's optional. Our sample size was 50. Our sample mean was 57.3, and our standard deviation was 10.2. On the type of inference, here is where we can switch to significance test and type in the information from our hypotheses. If you recall, that was 60 for the null, and for our alternative, we had a one-sided that was only the less than side. And by entering all the summary statistics that were given to us, you see that we get the results over here on the side, which is exactly matches up with what we were saying. We have a p-value of 0.0336 with a test statistic of -1.8718.